Okay, these problems are from section 12.2, which is arithmetic series and sequences. So it says you plan on taking a trip this summer that will cost you $451.50. You begin by saving a penny on the first day, an additional penny each day after that. So you save 2 cents on the second day, 3 pennies on the third day, etc. You will have to convert the pennies to dollars and dollars to pennies depending on the question, so make sure you read it carefully. So part A says to write a rule for the number of pennies saved on the nth day. Now I've probably given it away with my summation formula here that it is an arithmetic sum. However, this would be, on a quiz or test, your decision to make. So if you look at the pattern, so note that if I just kind of write out the sequence, I guess, you're saving a penny, then you're saving 2 pennies, then 3 pennies, then 4 pennies. I mean, it's pretty clear that it's increasing by 1 penny each day, which makes it arithmetic since it's increasing by the same amount. But again, that's your decision to make. So to write a rule, and I don't have the rule formula here, but I will write that out. For arithmetic sequences, it's a sub 1 plus n minus 1 times the common difference. If you go back up here to my sequence, my common difference is definitely 1 because it's adding 1 every time. And my first term is 1 because that's the first penny I saved. So I can fill in 1 for a sub 1 and 1 for my common difference. And if I simplify that, that's nice and easy. I get 1 plus n minus 1, which is just n. So my sequence is a sub n equals n. Part B says, how much money will you have saved after 100 days? And let's assume that that's, total. So we're going to now use the sum formula. So sum of 100 days equals n, and n would be my 100 days. So this is my n. A sub 1 would be how much I saved on the 100th day. So I'm going to go back up to my sequence here and plug in 100. And that's pretty easy, but I'm going to just put 100 in for n. So that's obviously 100. That's my 100th day. A sub 1, is how much I had saved on the first day, which was 1 penny. And then a sub n is how much I saved on the 100th day, and that would be the 100 pennies. And then divided by 2. And then it's just a matter of dumping that in your calculator, and you get $50.50. I converted that, I got 5,050 pennies, and then you, of course, divide that by 100 to get that into dollars, just to make better sense of it. Okay, then lastly, part C says, how many days total will it take to save $451.50? So now, I know my sum, so this is actually my sum of a certain amount of days. So that I will put in for S. I don't know how many days it's going to take, so that's my n. A sub 1 is day 1. I'm using the sum formula, by the way. A sub n, I don't know what a sub n is because I don't know what n is, but I do know that a sub n equals n because that's my sequence that I came up with. So if I kind of just write everything out here, I can then... Well, actually, and this, I'm sorry, so if I can erase this is in pennies, so I don't want that decimal there. Then if I just simplify a little bit here, so I'm going to distribute my n through, so that's n plus n squared. And then I'm going to multiply the 2 over, so this number times 2 and this side times 2 will give me 90,300 equals n squared plus n, because those cancel. And then it's, of course, a quadratic, so I'll get everything to one side. And not a fun one to factor, but it does factor down, and granted, this would take some grueling guess and check, I'm sure, and you'd have your calculator for something this large. But it does factor down to n plus 301 and n minus 300. And when I solve this one, I'm going to get a negative, so I don't even care to solve for that. So I know that n is 300. which tells me it's going to take 300 days to get a sum of this many pennies, or $451.50. Alright, I'll go through this one a little quicker. Domestic honeybees make their honeycomb that starts with a single hexagon cell, then forming a ring after ring of hexagon cells around the initial cell. The number of cells in successive rings form an arithmetic sequence. Okay, so dead giveaway. This is one of your homework problems too, by the way. So here's my initial cell, which is really, that means kind of not a part of my sequence, so like a sub 0. And then you can see that it's forming 6 rings around that initial, and then it's forming 3, 6, 12 more around that previous 6. So if I kind of write out well, the sequence, and I'll fill it down over here. So the first ring has 6 cells, the second ring has 12 cells. So it's definitely, you know, it's adding 6 every time. So that makes it nice and arithmetic, even though they told us. So my rule, because it's arithmetic, and note my arithmetic rule right here, is my first term, which is the 6, and we don't want to count the initial cell because that doesn't follow the pattern, plus n minus 1 times my common difference, which was also 6, and if I simplify that a bit, I get 6n, so that's my rule. And again, let me remind you that initial cell doesn't count because it's not a part of the plus 6 pattern, the sequence. Part B then says, what is the total number of cells in the honeycomb after the 9th ring is formed? And don't forget to count the initial cell, since that's technically not a part of our sequence. So now it's the sum because it's total, right? That's probably straightforward. So I can find the total after 9 rings, so that means n is 9. A sub 1 is my first cell of my sequence, which was the 6. A sub 9 would be 6 times 9, so that will get me 54. And then divide that by 2, and then you dump that into your calculator, and you get 270, but then again, don't forget that plus 1, so it's actually 271 cells.